Hi class, so today we are going to look at 9.2, Data Distributions and Outliers. Our essential question, what statistics are most affected by outliers and what shapes can data distributions have? I'm going to try to make the notes more condensed this time around. It's a learning process for myself as well. So what I did is I cut it down to 4 pages from your consumable. So those 4 pages that we're going to look at, and not even all of the pages, we're going to skip over some stuff, but we're going to look at page 389, 390, 393, and 398. Okay, so using dot plots to display data. A dot plot is a data representation that uses a number line and X's, dots, or other symbols to show frequency. Dot plots are sometimes called line plots. That is some academic vocabulary that you're going to want to add to your notes. We're going to look at an example. Finance. 12 employees at a small company make the following annual salaries in thousands of dollars. 25, 30, 35, 35, 35, 40, 40, 40, 45, 45, 50, and 60. Part A says choose the number line with the most appropriate scale for this problem. So we have 3 choices, and we're going to choose the middle one. We're going to use this one right here. And the reason why is that, and I also did this to help with our notes and move them along without you guys having to deal with me trying to figure out how to type, is the second number line is the most appropriate scale. It displays the numbers that match the data best. All right, so that is the scale we're going to use. So we're going to move on to part B, and we're going to create and label a dot plot of the data. We put an X above the number line for each time that the value appears in the data set. So what I want to do is create this number line, and I want to make sure I copy the numbers the same way that I chose. So it's going in increments of 10, starting with 20, and we're skipping 2 at a time. And this would be a good example to put in your notes. Now, we're going to be putting X's, or you can use dots as well, to represent those numbers. So our data is 25, 30. Let's go ahead and put those in. 25, 30. We have 35, 35, 35. There's 3 of those. And 40 shows up 3 times. 45 shows up twice. 50 once, and 60 once. Okay, so we have now just created and labeled a dot plot of our data. We're going to move on to the next page. And the only thing that I'm really concerned about on this page is the definition of an outlier. So an outlier is a value in a data set that is much greater or much less than most of the other values in the data set. It lies outside the data set. Outliers are determined by using the first or third quartiles and the IQR. I'm not going to focus on using those right now. Just want you to know that an outlier is a value that is much greater or much less than the other values. So add that vocabulary to your notes. We're going to move on to page 393 now. So I'm going to go to where it says explain 3, and I'm on page 393. We're comparing data distributions. A data distribution can be described as symmetric, skewed to the left, or skewed to the right, depending on the general shape of the distribution in the dot plot or other data display. So with these definitions I've highlighted in yellow, in your notes, you want to draw these three pictures, okay? So I want you to draw those three into your notes. Another thing you can do is you can print the PDF that I'm referring to from HMH. You can actually cut those pictures out and just tape or glue them into your notes. You can also cut them out of your consumable. You have to be careful when you cut out of the consumable because the pages are two-sided. So you might be cutting into something where on the other side it might be kind of important. And I don't have the consumable to look and see, but definitely if you were to print it and cut it, it would work out, or you can just draw it in your notes, okay? It's up to you. All right, so we are now gonna look at the last page, which is 398. And the directions say, for each data set, make a dot plot and determine the type of distribution. Okay, then explain what the distribution means for each data set. We are just going to look at example 14. So here's example 14. It's a cells one. The data table shows the number of days that specific numbers of turkeys were sold. These days were in the 2 weeks before Thanksgiving. So we have grocery store A and grocery store B, and we're going to take that data and make a dot plot for each grocery store. But we want to first figure out what our table values are going to be. So if you look at the range of values for grocery store A, it goes from, well, they're the same for both of them. So we vary from 10 up to 40 turkeys. And that's what's in the dark bolded column at the top. All right, so let's make our scale. Let's do grocery store A, 0, 10, 20, 30, 40, 50. And we'll do the same for grocery store B. Let's use a different color. 0, 10, 20, 30, 40, 50. That's going to let me put all of my data on each graph. So for grocery store A at 10, I have 2 turkeys. So this means I'm going to have 2 X's above 10. And for 20 turkeys, we have 5 X's. For 30 turkeys, we have 5 X's again. For 40 turkeys, we have 2. There's our dot plot for grocery store A. Grocery store B, we sold 10 turkeys for 5 days. We sold 20 turkeys for 5 days. 1 day, 30 turkeys. 3 days, 40 turkeys. All right, so we've made our 2 dot plots. The second part of the directions, though, we have to determine the type of distribution. All right, so we're determining the type of distribution next. And we also want to explain what that means for each data set. I tried to move things and now it's being weird. All right, hopefully that'll do it. So if we look at grocery store A, that is a symmetric distribution. Okay, and if I come back over here and show you a symmetric distribution is right here, because it's symmetric, all right? This means that the number of turkeys sold per day are evenly distributed about the mean, the average. The mean means the average. For grocery store B, though, it's not symmetric, okay? It's going to be one of these two. And it's actually, oh gosh, it's going to be right skewed. And I'll zoom in on that for you in case it's not coming out too clear. It's going to be skewed to the right because we have so much let me just zoom in. So the data for grocery store B show a right skewed distribution. This means that the store sold fewer than the average number of turkeys for more than half of the days.